Hey folks, welcome to another eventful learning day. This is Chaitanya Gundi. I am a data analytics coach and the co-founder of Swatch Data Analytics Hub. I am on a mission to help 1 million young working professionals achieve career growth by learning the skills of data analytics and data science. Data is a word which we hear very often in business world. We hear big data, we hear data analytics, we hear data science. These words are very common and ubiquitous. But what exactly pertains to data science? Is it same as data analytics? And what is big data? These words confuse many of the folks, especially the novices. So in this video, I try to demystify them and explain how they are all different and yet complement one another. Let's start with big data. Big data, by the name, it's clear that it refers to huge size of data. And not only the huge size, there is a huge complexity involved in this data. So obviously, this data cannot be managed by traditional database management systems and requires management through sophisticated systems that have come up in the form of data lakes and data warehouses these days. So what exactly is big data? Basically, it is characterized by 5 V's, which are the volume, the velocity, the variety, the veracity, and the value. Let's start with volume. Huge volume of data is generated these days in companies. Let's take the case of stock market, maybe a financial institution, maybe a large hospital chain, maybe a retail food chain like Reliance. Everywhere there is a huge volume of data in the form of customer reviews, in the form of sales data, in the form of internal administration data, maybe HR, maybe finance, and so on. Then there is velocity. The rate at which data is generated is mind boggling. Let's take the case of social media channels. The millions and billions of data in the form of videos, images, posts, sharing, comments, etc. happening these days. Then we have variety of data. Data is in the form of text, data is in the form of audio, data is in the form of tables, data is in the form of images, videos, or maybe a combination of one of these or two of these. So huge variety of data. Then there is veracity, which is nothing but how do we know the authenticity of the data? How do we know the reliability of this data? There is bound to be case of inconsistencies, duplications, and maybe because of spamming in the social media and email networks, we are not sure how much of the data is or reliable. Finally, we have value. The data is okay, but what meaningful value or information can be extracted from this data is a big question. So, combined, all these 5 V's characterize big data. The advanced database management systems and platforms these days that are available for managing big data, they are AWS Redshift. AWS is short form for Amazon Web Services. Google Cloud Platform or GCP BigQuery. Then we have Microsoft's Azure SQL Data Warehouse. We also have open source platforms like Apache Hadoop, Apache Storm, etc. Now, these platforms handle data which basically is of 3 types. Structured data, which has a proper schema or a structure like tabular information. We discuss about RDBMS, Relational Database Management System, which has structured information in the form of tables, rows, columns. Rows are called records, columns, fields, etc. Then semi-structured data. Let's take web pages, XML, and such type of data, which have structure to an extent, but we cannot say they are totally structured like tables. The third category is unstructured data. Let's say the comments of users on Amazon app. It's totally unstructured. There is no pattern, no restriction on the size, no formatting, and so on. So big data deals with these 3 type of data. Now, before understanding what is the relation between big data and other forms of data words like data analytics and data science, let's understand data analytics. Data analytics is nothing but extracting meaningful information from the data in the form of trends, behaviors, patterns, and so on. So, data analytics can be extracting the information from big data or maybe not from big data. Now, data analytics involves various steps, but primarily we discuss four types of data analytics. One is descriptive analytics. We have data and we talk about what is the most common value occurring in the data, or let's say what is the central value of the data, or let's say most of the data values are occurring in what range. These we use words like mean, median, mode, interquartile range, percentiles, and so on. We also discuss what is the variance of the data, how much the data values are varying from, say, the central value, the mean. So we have variance, standard deviation, and so on. Then we have, when we consider more than one variable, we have measures of association. How are they related? Are they related at all? So we have correlation, we have regression, and so on. Now, after the descriptive analytics, we have something called diagnostic analytics. So descriptive analytics tells us what has happened in the past. Diagnostic tells us why it has happened. What is the root cause behind the event? Let's say we have ice cream sales increasing as the temperatures are increasing in summer, and also the number of patients suffering from dengue is increasing as the temperatures are increasing. Now, when we plot the graph of these two variables, we find that they have a positive correlation or association. One is increasing, the other is also increasing, and maybe a huge or high positive correlation. But underlying cause is not clear, because the underlying cause is not straightforward. They are not directly related with respect to cause and effect. There is an underlying variable, that is temperature. So in summer season we see the sales of ice cream increasing, and in summer season we see mosquitoes breeding and causes of dengue increasing. So this causation and the studies are nothing but diagnostic analytics. Then we have predictive analytics. So we now have the past data and the causation behind the past data. So we predict the future trends, patterns based on this. And this is done by using ML and AI techniques. And then we have prescriptive analytics. So we know what is going to be the trend, or we can project to a reasonable accuracy. So what are the possible strategies or solutions or methods we can take, or measures we can take to minimize the impact of any adverse happening future event, or maybe we can try to extract maximum benefit in case of a positive future trend. So this is prescriptive analytics. So these are the four different types of analytics. And analytics also involves data visualization, because the data is presented to the senior management, and data visualization using sophisticated tools like Tableau help us in understanding the trends and projections very easily compared to the traditional PowerPoint presentations. Now, when it comes to data science can be understood as a superset which encompasses the data analytics as well as the big data handling processes, but which goes beyond these. So for example, if we are talking about data, we are talking about inconsistencies, inaccuracies in data, or duplications. So how do we normalize the data, purify the data, maybe using WinPure or uh, other such platforms and methods. Then once the data is purified, how it is stored in the warehouses. So part of it is overlapping with now big data management, and then analytics definitely is part of it, visualization. Then business intelligence tools like suppose Power BI and SAS are there, these also are part of it. And finally, designing of machine learning and artificial intelligence processes and tools using programming languages like Python and R, and these all come under data science. So for example, data science talks about supervised techniques and unsupervised techniques. So unsupervised means we are now instructing the machines to perform the future prescriptive or corrective measures without any human supervision. So for example, if we have a data of a credit card fraud, and we can identify the trend based on the causes and everything, and we can identify the measures. So now these measures, how they can be implemented by a machine without any human supervision. So advanced machine learning and artificial intelligence techniques. So data science basically requires the understanding of mathematics, understanding of statistics, understanding of scientific methods, understanding of analytics, and understanding of programming languages, and so on. So hope guys this video is helpful in terms of basic understanding about big data, data analytics, and data science, and how they are unique and yet complement one another. I would welcome any suggestions, any thoughts on this topic, and if you found this useful, be sure to post your comments. Thank you and happy learning.